Good morning everyone. I am Ms. B. Sangeethapriya from the Department of CSE IoT working in SNS College of Engineering. Today we are going to see about the introduction and on the operating system structures. Okay, what is an OS? An OS is a system software that acts as an intermediate between the user and the computer hardware. When we use a computer, we never interact directly with the hardwares like CPU, memory or a disk. Instead, the operating system handles everything in the background and allows us to use the system conveniently and efficiently. Example of operating systems includes Windows, Linux, Mac OS and the Android. The functions of operating systems. The functions of operating system is to manage the CPU executions, allocates the memory and deallocates the memory, handles the input and the output device, manage the file and the storage, ensure security and the protection, and last point is to support multitasking and multitasking environments. In simple words, without an operating system, a computer is useless. And now we are going to discuss about operating system structures. An operating system is a very complex software. To make it design and implement manageably, it is divided into smaller components arranged in a specific way. This arrangement is known as an operating system structures. The OS structures act as a blueprint that shows how the OS components are organized, how they interact with each other, how their services are provided by the kernel. A well-designed structure makes the OS to develop easier to develop, easier to maintain, easier to debug, and more secure and reliable. Types of operating system is mentioned below. Let's see one by one. The first one is the simple structure. The simple structure has no clear separation of a components, minimal design, limited functionality. An example of this structure is MDOS. In the structures, the application can directly access the hardware. There is no protection mechanism. A failure is one program can crash the entire system. Because of these limitations, the simple structure is not suitable for modern systems. Next one is the layered structure. The layered structures, the OS is divided into the multiple layers. The lowest layer is the hardware, the highest layer is the user interface, and each layer has service layer below it. Advantages: easy debugging, errors are also isolated to the specific layers, better organization. Disadvantages: performance overhead, careful planning required. Modular structure. In modular structure, the kernel contains only the core component. Additional services are added as a loadable modules. The modules can be developed and unloaded dynamically. The advantages is highly flexible, easy to extend, better performance than layered structure. Example: Solrus operating system. Next one is the virtual machine. Creates installations of multiple independent computer on a single physical system. The hardware resources like CPU, memory and a disk are abstracted. Each VM behaves like a separate machine. Multiple operating systems can run on one system. Example tool is VirtualBox or VMware. The OS uses the CPU scheduling and the virtual memory to provide each VM with detected like resources. The next one is a monolithic structure. The entire OS runs on one large kernel. All services such as process management, memory management, file system and device drivers runs in a kernel model. Advantages is our high performance, faster execution. Disadvantages is less secure, hard to maintain. A bug can crash the entire system. The next one is the microkernel structure. It keeps only essential service inside the kernel. Other service runs in a user space. The advantages of microkernel structure is improved security, higher reliability, easier to extend. Disadvantages is communication overhead. The Mac OS follows the microkernel concept using a hybrid approach. The hybrid kernel structure. Performance of monolithic kernel, stability of microkernel. Advantages is higher performance, modular design, better security. Example is Windows and Mac. The next one is the external exokernel. The exokernel is a minimal OS structure. It separates the resource production from resource management, gives application more control over hardware, avoid OS level abstractions. Advantages is highly flexibility, minimal overhead. Exokernel architecture was developed at MIT and it is mainly used in a research system. The conclusion of this PPT is the operating system is the backbone of any computer system. Operating structures define how components are organized and interacted. Different structures suit different system requirements. Modern system mostly uses hybrid and the modular structure. Understanding OS structures helps us designing efficient, secure and reliable operating systems. Hope you all understand in this video. Thank you.